Thank you, Alistair. So, in the spirit of a celebration of 10 years of Hadoop, I thought I'd take a look back at some of the things that we were doing 10 years ago. And myself personally, as Alistair said, was working on this. This is the compact muon solenoid. It's a 14-ton digital camera that sits in an underground cavern in France. And this thing generates a tremendous amount of raw data. These pictures that it takes are quite large, and there are lots of them. That data challenge is something that you have to tackle online. And even after we do all of the triggering and all of those kinds of things to reduce the data set, it's still a big data problem just to ship this stuff into an archive and then get it out into the hands of scientists who need to go cleanse and curate and analyze that data. And in addition to the data, we ended up with a distributed metadata problem, right? Because just finding the relevant data for the particular analysis that you were trying to do to go find the Higgs was a challenge unto itself. And so my team took a look at some of the NoSQL solutions that were out there that promised a highly scalable way to curate data and a good way to synchronize that data between different data centers. And we liked what we saw, and we liked it so much that we actually went and started a company around that, and specifically a company that delivered that open source technology as a cloud service. And then that company got acquired by IBM, where contrary to popular belief, the cloud is not a warehouse full of System 360s furiously going through punch cards. And that whole transition took place very, very quickly. And while that was happening, we had this world of big data. Hadoop has certainly had a tremendous decade, not just the project itself and the full spectrum of other projects in and around it, but also the whole huge ecosystem of vendors and applications and solutions that have been built on top of it. It's really quite a sight to behold when you see someone try to put it together like this, or you just go out to the expo hall. And so one of the things that we've noticed in talking to our clients is that we want to try to make it easier for people to kind of mix and match and pick and choose components and have some expectation of consistency across them. And so we got together with a few other vendors and clients and so on and put together this ODPI, which puts out specifications to ensure that applications that adhere to the specification can run across a variety of distributions. And I think this kind of initiative is really quite important when we start to look at portability. Many of IBM's clients, they've got on-premises facilities, they've got systems of record with lots of really valuable enterprise data, but so many of them are on this journey to move things to the cloud, and not just because of the elasticity of the cloud or because of the economics that public cloud providers are able to provide, but rather because in many cases the real business value is coming from new data sources that are being generated outside of the four walls of the enterprise. The Levi's example from earlier today, all of this IoT sensor data, it starts outside the four walls, so why would you bring it back in to analyze it? Why not just do it in the cloud? And I think that some of the standardization stuff is proving it out as a valuable way to kind of enable portability of existing applications. But even as we standardize, we know we disrupt, right? Mike talked about this earlier. Increasingly, Spark is the kind of thing that is able to displace MapReduce for lots and lots of applications, and certainly at IBM we are big believers in Spark and contributors to the project. And we do those contributions because we believe that there are lots of solutions that can be built on top that provide real business value. Even as Spark is there, though, who knows what's next? Whatever this badass laboratory is cooking up, there's going to be something else. Maybe in a couple of years, we're going to be talking about Flink instead of Spark. Who knows? But as we go through that, evergreen source of innovation and disruption, we still believe that the cloud is an essential platform for that kind of innovation. It's my belief that had we not had this simultaneous rise of public cloud infrastructure, Hadoop would have been much more slowed in its development. It's one thing for a company like Yahoo to be able to provision a massive Hadoop cluster on premises and go run it, but for those of us who were getting into the practice of building out these distributed algorithms, it was much easier to do that if you had the ability to rapidly spin up and tear down clusters. So we believe that this, constant experimentation and constant innovation is absolutely, dependent upon successful public cloud infrastructure. And that really goes to our commitment to the way we deliver our cloud. We're strong believers in the power of open architectures and open technologies. OpenStack and Docker and Cloud Foundry at the infrastructure layer, all kinds of different middleware projects at the the platform as a service layer, and on and on. A significant part of what we do at IBM is integrating these and delivering them in a way that makes sense for our clients. And not just for our clients, we do this for ourselves too. When we look at data preparation software like DataWorks, this thing began as a very large, complex code base, 40 million lines of C++. We looked at what we could do with open technologies like Spark, and we were able to rebuild equivalent functionality for that offering with a much smaller code base, and then take advantage of the rapid innovation that's happening in that community, and also a much easier cloud deployment model. So I guess I would say join us. We are open for data and open for business. If you'd like to learn more, stop by our booth. We have a session coming up at 11 o'clock where you can hear about what Spark is doing for our clients and some key business use cases, and see some live demos, including one by the author of the robot that we have out at our booth, who is taking on this unimaginable task of beating humans at the game of, yes, rock, paper, scissors. And if the big science stuff is interested to you, there's a session this afternoon as well that talks about how the LHC is now using Spark to predict which data sets are actually going to be most popular for analysis and proactively distribute those to different laboratories and universities across the world. So it's been a fantastic ride for that project as well. So with that, thank you, welcome, and enjoy the rest of the conference.